This is a classic analog TV tuner featuring a 12-channel rotary knob, where each click physically locks into place to select a specific broadcast frequency, giving it that precise and satisfying mechanical feel that modern electronics simply don't have. Housed inside a bulky metal enclosure, this unit was designed to isolate one channel from a wide range of radio frequency signals coming from the antenna, using carefully tuned circuits made of air-wound inductors and ceramic capacitors. As you rotate the knob, different combinations of coils and capacitors are mechanically switched in, allowing the tuner to resonate at a particular frequency and filter out all other signals, a technique that was essential for receiving clear analog television broadcasts. Inside, you'll find a dense arrangement of hand-tuned components, coils, variable capacitors, and shielding sections, each dedicated to a specific channel, making this not just an electronic device, but a piece of precise mechanical engineering. These tuners often used a superheterodyne design, where the selected signal is converted into an intermediate frequency for further processing, a method widely used in radio and television technology. Everything about this design reflects an era when tuning was completely physical, no software, no digital control, just pure analog circuitry working together to bring images and sound to life. Now, let's take a look at a more advanced tuner from a later era. This is a semi-digital TV tuner that uses I2C control, marking the transition from fully mechanical tuning to electronically controlled systems. Unlike the older analog tuner with its 12-channel rotary knob, this design replaces physical switching with electronic control, allowing the TV's main processor to select channels automatically. From the outside, it still has a compact metal shielding enclosure, but inside, the design is much more refined and space efficient. Instead of large mechanical switchers, this tuner uses integrated circuits along with varactor diodes and precisely wound inductors to tune across a wide range of frequencies. The I2C interface allows digital signals to control the tuning voltage, which adjusts the resonance of the circuit without any moving parts. As a result, channel selection becomes smoother, faster, and far more flexible compared to the step-based mechanical system. You'll still find coils and RF filtering stages inside, but they are now part of a more optimized and compact layout, working together with semiconductor components to achieve accurate tuning. This hybrid approach combines the reliability of analog RF circuitry with the convenience of digital control, representing an important step toward the fully digital tuners used in modern televisions.
If you enjoyed this deep dive into vintage electronics and want to see more such explorations, don't forget to like the video, subscribe to the channel, and stay tuned for more interesting teardowns and tech breakdowns. See you in the next one.